Welcome to this explainer. Have you ever typed a complex prompt into ChatGPT and just felt a genuine sense of awe? I mean, it's so easy to feel like there's an actual conscious entity sitting right there inside your screen, actively pondering your words, carefully typing a thoughtful response back to you. It's an incredibly powerful illusion, and honestly, it's one that has completely revolutionized how we interact with technology every single day. It just feels so wonderfully human. But today, we're going to pull back the curtain and reveal the magic trick behind that exact illusion.
Okay, let's dive into this. Is ChatGPT actually thinking? Well, the reality is a lot colder, but at the same time, it's mathematically beautiful. Underneath all that conversational charm, there is absolutely no conscious thought process going on. None. It is a mechanical, probabilistic engine. It's not pondering the deep meaning of your question, it's just calculating probabilities at a mind-bending scale. What feels like pure intuition to us is literally just extremely sophisticated math predicting exactly what should come next.
To really grasp how this all works, we're going to break this massive, complex AI brain down into 5 logical, digestible steps. We'll look at the language of tokens, the next token prediction loop, transformers and self-attention, how we control the AI's creativity, and finally, training and human alignment.
Let's start right in with Section 1, the language of tokens. Before the AI can predict anything, before it writes a single line of poetry or code, we have to understand its most basic building blocks. You see, the AI doesn't actually read words the way you and I do. Instead, it uses a process called tokenization. So before ChatGPT even starts forming an answer, it has to convert your text prompt into a sequence of these tokens. Think of them less as words and more like, say, Lego bricks of language. A token could be a single character, a whole word, or maybe just a common fragment of a word. And this is really the only way a mathematical model can actually process human language.
Let's look at an example. Take a recognizable word like ChatGPT. To the tokenizer, that single word might get chopped up into statistical pieces like chat, G, and PT. These fragments are the actual literal units the model ingests and analyzes. By breaking language down into these tiny, recurring fragments, the model becomes incredibly efficient. It doesn't need to memorize every single variation of a word that exists in the world. It just needs to recognize those foundational Lego bricks that make up the words.
Moving on to Section 2, the next token prediction loop. Now that we've got our token building blocks, we reach the absolute core engine of how this model operates. Now you might be thinking, hey, this just sounds like the autocomplete on my smartphone. But a phone's autocomplete is highly limited, right? It ranks candidates based on just the last word or two you typed. ChatGPT's next token prediction operates on a massive, almost incomprehensible scale. It analyzes the entire context window of your conversation to simultaneously score tens of thousands of potential tokens. It isn't just looking at your last sentence, it is looking at the entire structural history of your dialogue.
So here is the engine actually in action. It reads all your input tokens, scores every possible next token in its vast vocabulary, picks just one, appends it to your text, and then it repeats. But here is the wildest, absolutely most counterintuitive part of this whole system. The AI is completely stateless. It literally has no memory. It doesn't remember what it just wrote in any traditional sense. For every single new word it generates, it has to reread your entire prompt and its own previous answers from absolute scratch. It builds the context entirely anew millions of times a day just to give you one more token. Crazy, right?
All right, Section 3, transformers and self-attention.
Now, if this is all essentially just autocomplete on steroids, we really need to understand the architecture that makes it so remarkably accurate at understanding human context. Before transformers came along, AI processed text sequentially. It read left to right, step by step, and this was incredibly slow. By the end of the long paragraph, it literally forgot what the beginning was even about. The transformer architecture changed the game completely by allowing the model to process all input tokens in parallel. Instead of reading word by agonizing word, it looks at the entire picture all at once.
This wasn't just a minor upgrade, folks. It was a massive paradigm shift in computer science. As you can see from this famous quote from the groundbreaking 2017 paper, Attention is All You Need, by researchers at Google, this new architecture completely eliminated older recurrent networks. They essentially threw out the old rulebook and replaced sequential reading entirely with what they called attention mechanisms.
Let's walk through how this self-attention works in a practical way. Consider the sentence, "The bank will not approve the loan." How on earth does a math-based AI know that the word bank here means a financial institution and not, say, the muddy side of a river? Well, through self-attention, the model looks at all the other words in the sentence simultaneously. It mathematically calculates the relationship weights between every single word, zeroing in heavily on the word loan. By paying attention to loan, it mathematically solves the ambiguity of the word bank and perfectly captures the human context. It's a really brilliant solution.
Which brings us to Section 4, controlling the AI's creativity. So, the crucial point is, we have this incredible mathematical engine, but how do we actually steer it to be strictly factual or wildly creative? Well, we manipulate the AI's output using two major control parameters. Think of temperature kind of like a thermostat for creativity. If you turn it down, the AI takes the safest, most obvious mathematical path. Turn it up, and it takes risks and chooses less likely words. Then you have top P, which acts a bit like a bouncer at a club, dynamically cutting off the absolute weirdest, most nonsensical word choices so the AI doesn't just go entirely off the rails. These two parameters interact behind the scenes to strictly manage probability distributions and shape the entire tone of the response. To put that into perspective, a low temperature gives you predictable, focused answers. This is perfect for when you want the AI to write functional Python code, parse data, or give you strict historical facts. On the flip side, a high temperature gives you diverse, creative text, ideal for brainstorming marketing copy, developing characters, or writing a poem. Tweaking these settings behind the scenes is the exact reason why you can ask ChatGPT the exact same prompt twice and get completely different, completely novel answers each time.
Finally, Section 5, training and human alignment.
Let's move to and see how this all builds together, because raw prediction just isn't enough. If you just let the model predict the next word out of the box, it might babble aimlessly or be incredibly abrasive. It literally had to be taught how to act like a helpful assistant. This happens in 3 phases. First up is pre-training, where it essentially reads the internet to learn language patterns, grammar, and basic facts. Next is supervised fine-tuning, or SFT, where human experts literally write out perfect responses to show the AI exactly how to follow instructions. Finally, there's RLHF, reinforcement learning from human feedback, where humans grade its answers, essentially training it like a dog with treats, ensuring it is safe, polite, and aligned with what humans actually prefer.
So what is this system at the end of the day? It is essentially rolling trillions of dice. But these aren't just random dice. They are meticulously, mathematically weighted by all that human feedback, vast architectural design, and trillions of compute hours just to give you the perfect next token over and over again in a fraction of a second.
Which leaves us with this final, rather provocative thought to take away. If everything we've looked at today is all just math, tokens, and calculated probabilities, why does the end result feel so beautifully human? Next time you load up ChatGPT, keep this explainer in mind. Remember that complex, stateless loop running in the background, making absolute magic out of math. Thanks so much for joining me on this deep dive, and I'll see you next time.